Thank you very much, Jenny. So hello and welcome, everyone. So I saw we had a good crowd, but now with the screen share on, I hope I'm not going to get rid of all you guys who have been attending the previous session. It's a great honor to be part of this series again, after having spoken earlier this year during the first sort of lockdown, and we're back on the second lockdown. Hopefully we'll get you all entertained. That was a great session by Fernando, and I'm sure Julian will do the same with the next session. I'm going to speak to you about terraforming the cloud, and this is one of the most, should I say, dynamic talks that I have, because everything you talk about in the cloud changes dramatically and very quickly. And I did this a similar talk to this at the Groundbreakers tour in Latin America, sorry. And so if you've seen this talk, you can stay on because I rewrote most of it and I took a lot of slides out, and I'm hoping to make it a lot more interactive because last time I think I talked too much. And it reminds me I should probably get on with the context. So what I'm going to talk about today is some context around Terraform and why you may find that interesting. A quick introduction to some of the most important cloud concepts, Terraform basics. I'm going to introduce the syntax, and I hope I'll get to the demo this time in time. So I'm going to walk you through an example. And with that said, for those of you who don't know me, my name is Martin. I work for Accenture Enkitech Group over here in Europe, and I help customers with their projects around the world. And what I'm saying is strictly my own opinion. And I blog, and I'm on Twitter, and I wrote books and some other things that don't really matter too much for this talk. So speaking about the first part, about the context, I appreciate not everyone has been hacking Terraform or other automation toolkits. So I'm going to spend a little bit of time why this is cool. And maybe starting off with a personal experience is that I've been using a lot of GUI tools over the time of my career. But at one point where you get to the repeated tasks, where, say, for instance, with my LAMP VM, I want to spin up a new VM. And I want this to be a certain version of the Oracle database, and I want it to be installed. So what I do is, instead of running the graphical Oracle Universal installer all the time, or click through the Anaconda screens, this is boring after so many times when you've done it. So I really like to automate these things. And there are technologies out there such as Kickstart, which do this for you. And once you've got a VM, you can run Ansible to deploy the Oracle database, and it's all fun because you save so much time. The best example is like I kick off the process and go outside for a short walk, or grab a cup of tea, and then come back. And by the time I come back, I've got a fully patched 19C database, and that's cool. I can start working with that. Now, since the focus of the IT world has sort of moved away from on-premises local VMs, a different tool set had to come in mind, and that is Terraform in this case. So if you want to play around with, say, a free cloud trial, you can, of course, use the GUI to get familiar with the whole thing. But after you understood and grasped the concepts, it gets a bit boring to create all these auxiliary structures that you need to create just to start a VM. There's a bit more work to be done in the cloud than you would have done running on your laptop, starting a virtual machine. So Terraform comes in here, and there are a few of those features in Terraform which allow me to run a command and go grab my coffee or tea and come back, and then have the entire cloud infrastructure being spun up. The good thing here is as well that as I learn more about the cloud or new features come in, I can extend my Terraform code, and it then becomes more secure, hopefully, as you learn. And all in all, it's just so much of a more pleasant experience. So why does it matter? It does matter because in the cloud, you don't go through the same project cycles as you were doing on premises. which is essentially what this slide is all about. And in the cloud, like I said, the infrastructure that you create is probably best created using code, because that way you can't forget to tick a box or to select an option when you create something, because it's always the same, which means that you get it right. It's right 100% of the time, but it's also, you better get it right, because otherwise you can introduce problems and it'll be replicated in many places. So it's all fun. It's really fun. So what you do with Terraform really is that you declare resources and how you want to use them in code. You don't go and grab a machine, and you don't own the machines like you did in the data centers. And there are, over time, from what I understand, there are different philosophies on how you can create those virtual resources, virtual machines, or bare metal in the cloud. There is the idea of having mutable infrastructure, which means you're allowed to change what you deploy, or you've got immutable infrastructure, which means that you build something, and if you don't like it anymore, you build something new and replace the old with a new, but you wouldn't change what you do. So that's a typical approach you would find in Docker. And then you've got procedural versus declarative approach, which I'm going to cover a little later. It's a way on how you code what you want to create in the cloud. But you should definitely follow the infrastructure as code approach. When I'm saying here, sometimes you don't even have to provision VMs at all. That means that Terraform doesn't only allow you to create things in the infrastructure as service space where you create VMs or bare metal machines. Sometimes you just create a service. The service doesn't necessarily expose the underlying hardware to you. That would be the case with Autonomous, for example, with Autonomous Database. So that's kind of goes into the higher tiers in the cloud, like the SaaS and PaaS, software as a service and platform as a service. Why is Terraform awesome? I have been starting with this whole infrastructure as a code thing a little later than many others, so I didn't follow the first iterations of what was being used before. But it seems to be the winner when it comes to provisioning infrastructure as code in the cloud. There are other tool sets as well. There's CloudFormation. I think Azure calls their tooling Resource Manager. ARM. What's it stand for? I forgot just right now. But they have their own platform, and others as well. Oracle Cloud uses a thing called Resource Manager, which is using Terraform under the covers, and it looks very promising and super cool. But I have to admit, I haven't looked at it in too much detail, and it's changed a lot as well. But I want to cover the basics first. So it's always nice to understand how a GUI tool works. But in my opinion, it helps to know what you want to do before you have a tool that helps you how to do that. But definitely would like to recommend everyone to have a look at Resource Manager in the cloud. The other thing worth pointing out is that Terraform, in my opinion, and that also seems to be a consensus in the community, is not something that does configuration management. So Terraform provides infrastructure in many cases. That's not the total entire story, but in many cases you use Terraform to provide VMs or services, and these VMs are based on cloud images. So you can create your own. You can use a pre-configured, predefined one, and but that's just a bare metal or a VM shape that comes with the operating system and nothing else. Anything else you want to have on top of it, you need to provision yourself. So that's why I'm saying here you need to configure the resource once it's online. And this is where other tools such as Ansible, Chef, Puppet, and Salt come in. My personal favorite is Ansible, but there are many use cases for the others as well. And the configuration options obviously depend on the nature of your service. This slide is primarily true when talking about infrastructure as a service, because you have certain configuration options that you can pass in when you provision a platform as a service. And I'm going to show you later on when we get to look at the code that I have written in preparation for this talk. Then it's another question, before you actually go ahead and build loads and loads and loads of infrastructure using Terraform, is how do you want to deploy the application? Because quite frankly, it always helps to think of the big picture first, and then use a divide and conquer approach and break the big problem down into smaller, more manageable things. So common approaches that I wanted to highlight here on how people are doing cloud deployments is one, very common, very straightforward, not much to it, is infrastructure as a service plus Ansible. So you deploy a VM, then you run Ansible. Ansible does what you want it to do, say deploy JBoss, Tomcat, Wildfly, Node.js, maybe even the database, depends on really what you want to do. The other common approach which I have seen used is that you, instead of using Ansible to configure a sort of naked VM with the software that you want to deploy, you could use a tool called Packer. So Packer essentially allows you to grab a predefined Linux image or whatever operating system you fancy, say Oracle Linux, if you use the Oracle Cloud, and then you define what you want to install on top of it. And that is possible by means of using Shell or Ansible or other tools. So Packer will then go on, temporarily spin up a VM, run the Ansible playbook or whatever provisioner you pick. It will install the software. Say you want to have Tomcat installed, so it installs Tomcat on the VM. So it configures it maybe with your security settings, and then it finishes. Stops the VM, creates what we call a custom image. So that contains your specific VM with your customizations in the cloud providers repositories. So instead of then creating a new VM based on kind of the base, naked base image, you can spin up a VM based on what you just created. And that would be an example for immutable infrastructure, for instance. The other thing is a pass service that I've mentioned before. I'm going to tell you how to do that in a bit when we talk about the demo. What is not in scope of this talk is you could do the same thing using Docker or a container framework. So I'm not going to talk about those, which is saving me tons of time because I did that last time and it took forever. So in this context, just really briefly, Ansible, my favorite config management tool to complement Terraform. If you're not following the Packer approach that I just outlined, it means that you have a config management tool. You spin up your cloud infrastructure and you've got a control host on where you install Ansible, or you do that through some other means. But anyway, you need to have your VMs that you want to configure accessible from a certain vantage point. Then you run your configuration toolkit, and at the end of the configuration run, you've got your application stack completely deployed with all the parameters you want and all the security hardening that you can dream of. So that would be one approach. And Ansible seems to be the most popular of all the configuration management tools that I have come across. In other words, there is a lot of talent on the market, so it's easy to get started and keep your code maintained. It's one of those open source things that if you figure out that you find the most suitable tool for the task, but it's also the most obscure, it's difficult to maintain something in the long run if you want to. But anyone who hasn't learned and mastered Ansible until now, it's actually pretty easy to read. Of course, that's a subjective thing to say, but yeah, I found it reasonably easy to read, even not being an Ansible developer at first, but I got intrigued and learned how to write those playbooks. So it doesn't hurt to learn Ansible either, because like I said, it's not only a lot of talent on the market, but there is also demand for this. And it's easy to use because it's agentless, which is something I very much like. You just need a Python interpreter and SSH access, and that's it. So Ansible. Good thing. Right. Yeah, we're good in time, so let's move next to the next section, which is talking about concepts. And I deliberately tried to pick the most complex architecture picture that I could find. So not sure if you guys are aware of the Architecture Center for Oracle's Cloud. Oracle has published a lot of blueprints and best practices and how-tos and what have you in this URL, which you see down here, docs.oracle.com, solutions, OCI, pilot, light, DR. So this is an example on how you could create an inter-region DR solution for your database application. I mean, when we're going to talk about the example, when I talk you through the code, it's obviously not going to be this complex, but I just wanted to show you that you can do things that are rather complex. And there are lots of concepts that you need to understand actually before you start hacking Terraform scripts. So it's easy to get started by just copy pasting code from the usual suspects, Stack Overflow and what have you. But I found it quite beneficial to pause and do a bit of research on what I want to achieve and how you would achieve that. Take out a piece of paper. I'm old-fashioned. Take a pen, draw a little chart of the application I want to deploy, and that makes it easier later on as a reference, because most of us are, well, we can, as humans, we process pictures probably a little better than we process code. I'm going to show you later what I mean with that. So the concepts that are worth understanding on this slide definitely are the concept of the region. So this is kind of what the name says. This is one area where the cloud provider has data centers. And then you've got, I don't know, they don't have them here, but most regions are subdivided into units. They call them ADs in Oracle's cloud. And the concept exists in others as well. It's just essentially a separate data center. Then you've got a virtual cloud network, which is the starting point where you deploy stuff. You've got public subnets, which you subdivide your VCN into. And you've got private subnets. As the name implies, some of them can be accessed from the internet, some can't. Just be careful with anything you expose to the internet, because you'd be surprised how many attacks and port scans there are taking place every second. It's terrible. And every security vulnerability that can be exploited is most likely going to be exploited. So be careful with that. And the other thing I wanted to say is the flow of information over here. So you've got information coming in, going through on the left-hand side. You've got your public subnet, there's a load balancer, which is a pretty common thing to front end your application. This is where you can do TLS or SSL termination. Then you go and pass on to the app servers. These are part of your backend. So there are various policies on how you can route the traffic to your app servers. And those can then use a database, for instance, if they are database-centric applications. Essentially, that's what it does. And of course, you've got the whole plethora of other services around there, like file storage, block volumes, volume backups, object storage, what have you. Depending on the nature of your application, you can include those in secure ways by means of a service gateway and so on. So what I want to say with this is really just, start off with a good old-fashioned plan. I found that useful. And once you have actually worked out what you want to do, you can then go about implementing what you want to have. So this leads me to the documentation. The documentation is pretty good. And now I'll see if I can switch over to live. So this is the Oracle documentation, as you can see on docs.cloud.oracle.com, but there's also the Oracle Cloud Infrastructure Provider here on Terraform, because the cloud support for Oracle's cloud is now integral part of Terraform, which is nice. And there you've got your various things that you can build. So you just need to make sure that you create them in the way your application needs them. And yeah, that's pretty much it. So you will start understanding the Terraform syntax, which isn't terribly difficult. I mean, it's takes a little while, as everything new. It takes a little while to get used to, but after all, it's not rocket science. Doesn't look particularly pretty, in my opinion. But once you get the hang of it, it's just stringing various resources together in a way that actually fits your architecture design. And yeah, both the architecture design, of course, and the code you can put into source code control because it's code, text files with certain exceptions I'm going to talk about in a little bit. But you can then have this version controlled, and you can always go back to what it was before and why does my code do something now, and where does that come from. So if you've got a good documentation of your process and a good documentation in your code linking the two together, you're almost set to go. Okay, well, I've touched on this just briefly. Security is key. In the cloud, the bad guys are very close, whereas in your on-premises environment, you could have 42 layers of firewalls before you're in front of your database. And it would have been difficult for an external intruder to actually get all the way through those 42 firewalls. With the cloud, everything is much closer to the internet, and with it being much closer to the internet, it's important to secure what you do. Specifically for everything that's public facing, there is always a risk that the bad guys are exploiting a zero-day security vulnerability, and that's completely independent of Oracle's cloud. I mean, this is anything you have facing the internet. So make sure to involve the security team. If you don't have one, it's maybe a good idea to temporarily at least get a security team to help you with the design and the implementation, and also later on maybe validate what you have built. Most cloud providers give you pretty good security best practices guides, and they're worth reading just to get a better understanding. Even if you're not a security person, it does help. Reduces friction with the security guys as well. The other thing I tend to advise everyone who's doing something they aren't intimately familiar with is to start small. Get a feel for the new technology. If you've been a sysadmin with a big gray beard and you've been doing on-premises systems for a long time, it doesn't necessarily come natural to many working in internet-facing cloud infrastructure. So get a hang for it. Learn the technology before you go all in. That's something maybe worth considering. And yeah, use your cloud provider's security tooling if there is such a thing. Okay, now getting to the main part of this talk about the Terraform config and the syntax. So you saw a little bit of the syntax in the example print screen that I had out there with the documentation reference. But there's obviously a lot more to it. So to start off with, Terraform uses HashiCorp configuration language, HCL, and it's not the only tool that uses it. So it's not a one-off if you learn it. Terraform 0.12 introduced a new release of the HashiCorp configuration language. In my opinion, it's a lot more pleasing to the eye than HCL, the old one. The trouble is, if you look at examples, most of those will still use the old language. And so as a rule of thumb, if it's got lots of dollars, open curly braces, and text in double quotes, it's probably HCL1. It's backwards compatible, so it works, but if you write new code, and if you haven't written any code and legacy code now, it's probably best to start with HCL2, actually. Documentation is great, so the link is down here, Terraform.io, docs configuration. I can only recommend having a look at that. I believe they also have sort of tutorials and learning labs that you can run, so you don't have to install anything yourself to do so. Nice. Gentle introduction to the technology. Terraform 0.13 has gone live. Well, it was just live in June when I did this the last time. It's actually been around for a little while, and it enhances HCL2, but it's not a massive change from what I can tell, such as HCL1 to 2. I would say that HCL2 isn't too complex. The language is comprised of a few basic elements, which are blocks, arguments, and expressions. And I'm going to show you a few examples in a little bit. The main purpose, from what I can say, is to declare cloud infrastructure, not necessarily cloud infrastructure, but to declare things in the cloud, to create things in the cloud. That could be services and platforms as well. Okay, so here we've got an example of one of those things. As you can see, the whole thing is a block. So it starts with a block type. Then it's got a block label. And then you find identifiers in there, and you find expressions. And the syntax is actually straightforward. So resource means create something tangible. Well, if you can talk about tangible things in the cloud, then the block label usually says which type it is. So that would be OCI core VCN. So it could be something to do with the network. So I remove those, and then you give it a name. This is just anything you like to give it a name. And so then the first thing you could do, if you didn't know what that resource was, you could say, I want to know more about the OCI core VCN. And there we go. This is core resources. We're looking at resources. I should have practiced that more. Sorry, try again. Core resources. If I scroll down there should be something. There it is. So it's always good to, many times you get to see those resources examples on GitHub as an example. Somebody has put it out there. Rather than just running that thing, you may want to go and look at the docs, what it is. I mean, with a VCN, it's fairly straightforward, and you probably don't need the documentation. But the documentation in this case is actually pretty good. It takes you to the relevant things that you need to know. It also has like the most important things written down here. And once it goes here, and you find the example usage with all the attributes that you can have, and that it defines, what you need to feed it. So like a CIDR block, so that's the network range. You need to tell it where to create it. You can give it tags and DNS label and all these things. So if you've ever gone through the GUI, those will be familiar pretty straight away. So in my case, I give it a CIDR block, so an address range, and because I don't want to hard code this, I put that into a variable. I talk about that later. The same for a compartment, this is obviously Oracle Cloud specific, so I need to say where to create it within my tenancy. I give it a display name and a DNS label, so pretty straightforward. Sorry, I should have said this is the official documentation, and this is kind of what I make of it. But I'm going to talk about those in a bit. So we talked about blocks and we talked about attributes, but now the final thing to mention is the Terraform expression. And that's probably the most powerful feature and the most confusing, but it's got lots of documentation too as well. It can be simple, and in most examples that you find out there, it is simple, but it can also get quite complex, which I don't want to do. I want to keep it simple for now. A very common use case for those expressions are to reference other things. So let's walk you through and say if I can get my pen. So I've got a pen here, and it starts off with a variable. So I say my CIDR block for the VCN should be this. This is actually lifted from the docs. So it's a /16 network. So now if I'm using, I create a VCN, I can now reference this guy down here. So I don't need to hard code this. I can put that into one central location and then I reference it here. So I need to say this is a variable and what variable name it is. And I should use a tablet and a pen for this. I'm using a mouse, which is probably not ideal. Anyway, the same is true with the compartment ID. I also put that into a variable, and there are a few other things. And later on, when I create an internet gateway is required if you've got a public subnet and you want it to be accessible from the internet, which would make sense. Otherwise, there wouldn't be a reason to have it public. You can then reference your components. So again, I've got a compartment which I've written down as a variable, but now I can also point to the VCN. Let me see if I can do that. Good thing I don't rely on art to make a living. So you can see the VCN is a reference to the VCN I just created, which is a 3-part thing. So this is the resource type. Here's that. It's a core VCN. Then I need to tell which one to use, simple app VCN, simple app VCN. And because I need the ID, I just use the ID. So there is a property within the VCN, which is the ID. So if I look at this, there we go. So this is the VCN's Oracle OSIT, which is kind of the unique identifier the Oracle Cloud uses. So instead of hard coding that in here, I can just say, hey, once you created that, use this OSIT, so I can reference it. And yeah, that's how you use expressions in many cases. I mean, there is a lot more to this, but for the purpose of this introduction talk, that should be enough. Look, I even had bubbles to point that out. I was joking about VI and Emacs just prior to this talk, and I actually think there might be a better editor to write this than VI, because everyone knows that VI is one of the best editors out there. There is a really good one that I like. However, I do understand that this is kind of a delicate issue. People have their own preferences for editors. So why did I use Visual Studio Code? Simply because it can be extended quite easily. And Terraform code without syntax highlighting is really difficult to read. There are, of course, other editors which give you syntax highlighting. However, I found Visual Studio Code to be super useful. Not the least because you can actually open a terminal in Visual Studio Code and you can just type Terraform apply, Terraform plan, whatever, just to see if what you typed actually does make sense. Yeah, and it comes with excellent Git integration for source code control. That is very important. And if you're a diehard VI person, you can even have a VI key map on Visual Studio Code. I mean, you can have multiple. I think you can even have Emacs, but who would want to have Emacs key mapping on their editors? All right, source code control. The other thing, it's infrastructure as code, and every code should probably go into some sort of version control. And why is this perfectly possible? And there's nothing against doing this all locally. As soon as you work with these things in your team, you get to use a common repository. So my recommendation is to make use of a version control system. But it's very important to have a valid git ignore. Thankfully, for those of you who haven't seen it, there is a git ignore template that you can start with, which you include in your project, because there are certain files within your code, some of those which are created by Terraform, but there is also state, which I'm going to talk about later, which you definitely should not include in version control, because the Terraform state file is a text file, and it can contain stuff in clear text. That includes passwords. So You don't want to commit sensitive information in a version control system, full stop, because if people break into your infrastructure using the keys, you can't really call it break-in, in my opinion. So when you create this is GitHub. So if you create a GitHub repository, I just came up with one. It's a private repository, and I'm even too lazy to add a description, but I'm not too lazy to add a git ignore. And like I said, there is a template here, so you can use the Terraform template, and that's a starting point, I should say. Don't use that without checking it to see if it fits your use case. Use the state file. I'm going to talk about that, like I said, in more detail later. The state file is that what Oracle says, don't commit sensitive information. The state file would be one. And obviously, depending on how you do your setup, there's also sensitive stuff in there. So state information, however, is key. So you can't work without it because, as I said, Terraform is a declarative language. So you say, I want 5 VMs. It will give you 5 VMs. If there are 3 already, it won't give you 8 total. It will give you 5 because it knows I need to create 2 more. So that's what I mean by it checks what exists already using the state file. Anything that it doesn't find, it creates. Anything that's there too much, it will be removed. And you can also change certain things. Going back to the documentation, you'll find something there where they say updatable. So you can say, if you don't like the freeform tag, you can change it in the code, you run it again. It doesn't tear the resource down, it will just change that attribute. But there are other attributes like which base image you use. If you change that and you run Terraform, then Terraform's command to apply it, it will tear down the VM. So be careful with that. And then you get to slowly but surely, we get to the implementation. So this is about Oracle Cloud Infrastructure. So it depends on the provider. Each provider has its own requirements. I'm not going to talk about what you need for the Oracle provider because that's been addressed by other people to a large extent. So I'm going to just show that during the code session. Like I said, it's always good to know what you're doing in all situations in life, so to say. So I start with my application diagram. Which building blocks do I use? Do I build something myself? Do I use a service? The architecture center I talked about. You may just go there and get inspired by how other people do things, and then draw the solution first before you start building it. That doesn't sound particularly agile, but in my opinion, it's very beneficial because you don't spend a lot of time troubleshooting and hacking, and you're always tempted to go back in the GUI and just to do a quick little modification here, which of course you don't do in the code, and then nothing matches and you start from scratch anyway. So with the Oracle provider, I'm going to go over that during the code session, so I'm not talking about that. So you just need to feed it a lot of details. And once you've done this, you can run Terraform init in the current working directory, and it will pull the necessary provider from Terraform and store it locally. Then you start off defining your resources. Just like in the GUI, if you want to create something, you need to have certain resources like a network, subnets, and then you need to have the firewall rules and all that. Anything you would create via the GUI, well, not everything, but pretty much everything you create via the GUI, you can create using Terraform. Like I said, you can reference things, so you don't need to hard code anything. All the resources are documented. I showed you the documentation just now. There are lots of examples on GitHub, but as with everything you find on the internet, don't just trust it. Make sure you understand what those examples do, and maybe test it first before you just take it and deploy it into production. But that goes with everything you find on the internet, right? The other thing, so just I'll show you in the code later on. So you, instead of hard coding stuff, you can have variables, and you don't need to hard code the variables either, because you can use. Damn it! I don't have an example, because you can have a script, a bash or a shell script, where For instance, if you wanted to define the tenancy OSID, you don't want to hard code it in your variables, you can then say export tfvar underscore, what was it, tenancy OSID equals, and then a string. And at runtime, Terraform will pick it up and it will feed it in. And that is actually a very valid security thing as well, because you don't want to have passwords in your Terraform scripts, like you don't want to have passwords in your code full stop. Because I might have said it before, but don't commit sensitive information into a version control system. Let that sink in. Okay, well, then you've got another concept, and this is useful for printing things on the screen. So for instance, you just signed up for a trial. You probably don't create a VPN as a service to your cloud infrastructure. So you spin up things and you don't connect via VPN, but you still want to be able to connect to it. So you tell your instance to actually start up, get an IP address, and later on you use SSH to connect to it. And this is pretty much what all the examples in the internet give you. Spin up something in temporary resources, connect to it, have fun, tear it down. So what you can do here as well is you can define a virtual machine. So the OCI core instance is the virtual machine resource. You give it a name. I call it Bastion instance because I'm not very creative as a person. So that's the thing that is accessible from the outside. And yeah, so then I don't know what IP address has been assigned to it, because it's in this case, it's a public IP address, but not one of the pre-registered ones. So it'll be dynamically assigned whenever I spin up this resource. Now I can say I've got an output variable called Bastion host, and that's what it shows up as. And it will print the OCI core instance, Bastion instance, .public IP. So that'll be the public IP of this resource. So then that way I can just say SSH OPC at whatever IP address and connect. Finally, before going to the demo, I'm going to talk about the state file. So first of all, don't check it into version control. It contains sensitive information like passwords. And by default, it's a local copy. But what if you have two developers modifying stuff? You will quickly get out of sync. So you need to have a common location for the state file. And that really is all I want to say. You've got different backends that you can use. You can put it onto object storage, for instance, and then you pull it from object storage. It gets modified, and you put it back. And so the next person runs a Terraform command to see what the state of play is. They will know what has happened. So managing the state file is important, but it's definitely not straightforward, because not every backend implements locking. So you back to the problem. Whoever writes last, those changes get persisted and everything else is lost. So check the backend documentation, I would like to say. And never ever commit the state file or any other sensitive information to a resource, to a source code version control system. I think that should have now become clear. What I'm not going to cover here is the do not repeat yourself paradigm by using modules. You may want to separate your code into modules, and there are a couple of blog posts that I can reference. And well, having said all that, let's have a look at how I did things. Hopefully we've got a few more minutes left. I think we've got 5 minutes left. So I'm going to talk you through the code I wrote. First of all, the git ignore file. So this is just my git ignore. So this is where I make sure that I don't have the Terraform state file part of the version control. .terraform contains the drivers and the source, well, the Terraform, the actual implementation of the Terraform provider. So you don't want to check that in either. Crash log and a few other things you don't want to get in. And there are some others here for my personal use cases that I don't want to have in. Like I said, have a look at the GitHub Terraform git ignore file and adapt to your needs. So Then, oh no, I mentioned variables. So I've got a bunch of variables that I'm referencing here. Some of them have defaults. So for instance, the subnets that I'm going to use. Oh, I didn't show you the architecture diagram because I don't have it. Apologies. It's actually a simple application. It's got a bastion host, it's got a load balancer. Both of them are in their own public subnets, and there is a backend of a couple of app servers. They're running a Java servlet that connects to an autonomous database. So in my main code, I'm defining this is for OCI, and this is the tenancy that I'm using. In here, I create the resources, like this is my bastion host, that'll be spun up. Then there is the output variable, which tells me which IP address it gets. And then I've got an app server, and I've got another app server. So in here, you just define how they look like. I'm not going to walk through all of these because I would be taking too long. This is in private subnets, so these aren't directly accessible from the internet. However, I still want to expose the application. You go away. So I'm using a load balancer. So the load balancer exists in my in its own dedicated public subnet, and it's got a health checker for the backend, and the backend is on a port that I define as a variable. So this is going to be port 8080. And then I've got those two servers. I put them into my backend set. So I've got a backend set containing two app servers so that I can round robin between the two. And the load balancer, actually, it listens on port 80 on the public IP address where it's getting created. And at the back end, I've got an autonomous database. So I've already used my free tier autonomous database. So this is not a free tier autonomous database. It goes into a department. This is the smallest I can create, 1 CPU, 1 terabyte. It's got a name. And here there is this thing that I wanted to talk about. It's many examples out there. You find a password hard-coded in here, but that's not good, because somebody who looks into GitHub with the right privileges, or if it's a public repository, you look into GitHub and you find out that there is an autonomous database in this compartment, and it's accessible via this password. So why don't I try see if I can log in? Oh, not so very good. Definitely not worth it storing passwords in here. And the most difficult part actually is to create all the network, because these things, the app servers, the bastion host, the load balancer, and the autonomous database, they just can't exist in thin air. So you need to create a network around it, like a VCN first, then various subnets where they are. The subnets need to be told to be either public or private. And more importantly, you also need to create lots of rules as to what's the egress and what's the ingress traffic. And I'm not going to go through all of those. I'm really hoping at some point that I can make this GitHub repository public. Right now it isn't, yeah, hopefully I'll get it to a point where I'm happy with the code. I think it's pretty well documented right now, but I'm not 100% sure if it's good enough for my own standards. And this is where I think this is the beauty of the Terraform provider, or the Terraform language. If I wanted to create this through the GUI, I would have to create everything that you see here, starting with the name of resource. I would have to create this. It would be an awful lot of pushing the mouse, and I'm not a great fan. I mean, it's cool to do it initially to learn how it works. On the other hand, after the second time, I mean, let's just look at the number of resources you're creating. Most of this has to do with firewall rules, so to speak. We call them security lists and network security groups, but it's an awful lot to create, and it's easy to get it wrong. Specifically, if you do it like the third time and it's 5 o'clock and you really want to get home, and I can assure you at that time you're going to make a lot of mistakes. So I don't like mistakes, and I like to get finished on time. And although it may look like it's enormous amounts of effort up front, once you've got this coded, all you need to do is starting it. And with that, I want to ask the organizers, how much more time do I have?
You can still go for like 10 minutes, not a big deal.
Okay, cool. So, because thank you. Now let's look at what that is in real life. So imagine you have coded all of this, and now you're about to start it. I hope it's readable. This is the simple app I'm talking about. Then you say Terraform plan, and it prints what it will create. So this is the first thing where you need to be careful. Make sure that it does create what it's supposed to create. And then you say, it prompts you, do you really want to create this? And well, if you're brave enough, then you can say, okay, well, go ahead and create it. So this is the beauty of having recorded this. It will not fail. And more importantly, instead of 4 minutes, it only takes a little bit of time. So I'm going to skip forward because this is pretty unexciting. So here you can see the thing it creates. It's the autonomous, the ATP instance that I created. And there you go. It's created cloud infrastructure. My application at least, the raw shell is ready. I've got a load balancer. I've got 2 VMs that act as my application front end. I've got an autonomous database as the back end. And now I can SSH into this IP address and log in and deploy my application. And so what did that create? So I'm going to walk you through real quick. So this is if you go through, use the GUI to show what it has created. So I've got my Bastion host. It tells me its private IP address. It tells me the public IP address when it was launched, where it is found. I look at the virtual cloud network, which is the simple app network with all the subnets, with all the route tables, my internet gateway, security lists, and so on. One thing I blogged about recently, I should probably stop here. So I'm using network security groups because they're pretty cool, but they don't exist in isolation. And if you create a network security group and don't change the default security list, which is the older way of controlling access in and out of a subnet, you open it to SSH for everyone. For anyone who is interested in the details, look at my last blog post. So what I did here is I created a strict security list which doesn't allow any traffic in. I want everything to be controlled via network security groups. And yeah, there you can see this is the security group for my database. So using the documentation, the autonomous database documentation, I opened port 443 and 1522, so the listener and Apex odds and the rest. So now if I'm in the simple app application network security group, I can access those. So my app servers essentially have access to the database. And I think next thing is I'm going to show you the load balancer. Yes. The state is currently unknown simply because I haven't deployed my application, so there is nothing it can talk to. So it would talk to something in my backends. So those two are my application servers. It would talk to port 80 on those, but there is nothing on port 80 listening at the moment, so it gets the status unknown. Once I deploy the application to these application servers on port 80, that would be something they listen to. At which time you can also, hang on, stop. You can use the IP address here that is, assigned to the public subnet, so it's accessible from the internet. And there is my autonomous database. Again, this is not a free tier. This is a payable autonomous database. And now I could just go back and download the DB connection details and deploy that together with the application on the application servers. And I've got a wonderful application. And yeah, so that was pretty much what I had to say today about terraforming the Oracle Cloud. I do appreciate it was a bit of a quick run through. So wondering if anyone had any questions before we need to wrap up and hand over to Julian. I do think we had something in the chat box.
There was there was one question in the Q&A for you, which is what are Terraform's competitors? So I think subtitle, what else can I use instead
What
of
else can I
Terraform?
use? Yeah, well, like I said, there is, Terraform is kind of the most generic one, which you can use. And all the big cloud providers and quite a few of the smaller ones, they give you support for their cloud infrastructure with Terraform. But before Terraform came around, I think AWS used CloudFormation. Azure Resource Manager, I think ARM is what they use in Microsoft, and there are probably similar things there. But these are specific to those cloud providers. Whereas if you learn Terraform, you can code for AWS, Azure, OCI, what have you. But just don't be fooled. It's not Java. It's not you don't write one Terraform script and after changing the cloud provider from AWS to OCI or whatever, you can't just run this, because these resources here, they are cloud provider specific. So you need to be aware that it's not write once, run everywhere. It's you code for the cloud provider you intend to use, and it's not as simple as changing the bit up here, the provider bit, to something else, and just run it without changes. That just doesn't work. Okay, I think there are a few ones in the chat as well.
Now in the chat, it was like Christian debating about weather and Nutella.
Yeah, well, the sun's setting now, Christian, but it was 11 degrees when I went for a run this afternoon.
Martin, I have a question for you.
Go for it.
Well, like when you install the database, for example, you can use the graphical interface. At the end, you can generate a response file. So the next time you just run the response file and you don't do anything by hand.
Yes.
As far as you know, is there something like that using the wizard that the web interface of the Oracle Cloud give you, allow you to generate Terraform scripts, for example?
Yeah, wait for my presentation, Johnny.
Oh,
I was about to say something, but I am not. I don't want to steal your thunder.
Probably you have another idea than I will mention, but let's see.
Should I just try it? You can reverse engineer. You can reverse engineer what you build.
Yes.
So it's yeah.
So you can point like to an existing instance or an existing subnet and say, "Give me the code for this object." Then.
Yes.
Something like that.
Yeah.
Okay.
That's a relatively new thing. And Julian, is that something you talk about?
I'll talk about OKit.
Well, then I can probably say yes, but you're right, Johnny. So you build something using the GUI, and then you just point Terraform at what you created you created in a compartment, and then you can just dump everything into Terraform files, and it will do it. So
Terraform does it, not the Oracle GUI.
Terraform does it, and more recently the Oracle Resource Manager. You can reverse engineer that as well through the GUI. There is a post by Gleb, well, I can't ever pronounce his name. You know, the Canadian who runs like 40 miles just before breakfast. I'll try and find the post. Yeah, he's impressive. He's an impressive runner, and he's got a very, very good blog as well, but I can't pronounce his name. So let me see if I can grab that and post in the chat window, because I wouldn't be able to give his name justice.
Because like you said that you didn't want to like create subnets by hand again and again. That's why you had this long piece of Terraform code doing it. I say, I'm even too lazy to start writing that piece there. So I say, if I created one, just give me the copy of this one and let me rename it and duplicate it every single time.
Actually, I think this is a pretty useful way of learning how to do it. because
I'll have your way, Johnny. Then.
Okay, then I have to stay. I have to stay online for the next session. Done.
Yeah. Okay. Well, any other questions? Feel free to ping me on Twitter. But it's already 4:10, so it's Julian's time, and I don't want to overrun too much. So
it's all good. We have a 10 minutes break anyway now.
Oh, we've got a 10-minute break.
Yeah, we
Sorry.
have a break. Yeah.
Okay, so let me find the blog then, and.
But I'm even more lazier than Martin in writing scripts for deploying infrastructure.
I'm glad you added the last thing, because the other thing, the only person more lazy than me is Garfield.
Well, that's just levels, you know. Martin does something, then we wait for Julian to tell us how you could automate this, and then we just use what Julian did based on what Martin did, based on what someone. So you see, at the end of the food chain, we're just waiting for the output of you guys.
Then try to find the error in the whole process.
I believe it's only like the stuff you have to wait. You have to wait and to have a good RSS feed to their blog, so you can download their stuff.
That is the ultimate laziness.
It's easy to automate everything if you have other people doing the automation.
Martin is providing his Git repository. That should be enough.
Okay, so I'm pasting the link to the blog posts about resource discovery. I hope that got through to the panelists as well as the attendees.
Yes, it has been sent to everyone.
Yeah. Okay, so that's the post I was referring to. So that's when the feature came out. I think he was one of the first to write about it. But yeah, it's just one way to learn. You use the GUI because it's it could be more intuitive, and then you just download what it did and take that as inspiration. Okay, well, thanks everyone who's attended. Thanks very much, guys, for having me for another time. I'm so glad I didn't have any sound issues. Yeah, looking forward to the next talk.